Okay, let's look at this exterior angle of a cyclic quad. This is the reason we give when we use it. And it turns out that this angle out here, C1, you see this angle as this line goes out? It's on the outside, it's on the exterior. It equals this opposite interior angle inside the cyclic quad. They're just equal to each other. The proof is actually pretty darn simple. How do you know it? Well, you know that C1 plus, C2 plus A is 180 degrees. Well, that's opposite angles of a cyclic quad. But we know C1 plus C2 is 180 degrees because of angles in a straight line. Well, if that means that the only way these could be equal to 180 is if A and C1 were equal to each other, because C2 plus A and C2 plus C1 equal the same thing. You could just let them equal to each other, subtract the C2s, and you get this, that C1 is equal to A. And just like that, you know, if you have two angles that are supplementary in a quad, it means you could put a circle around it. It means that the quadrilateral is cyclic. So you can use opposite angles in a cyclic quad to prove that a quadrilateral is cyclic. The same story is, if I just have a quad and I know that this angle A out here equals this angle right here, then I can say it's a cyclic quadrilateral. And the reason you go the converse of the exterior angle of a cyclic quad. The converse. If they ask you to prove, well, if you can show angle A is equal to C1, the exterior is equal to this interior angle in the quad, you know you can put a circle around the 4 points. It's a cyclic quadrilateral.